In today's lecture, we will begin with the concept of absolute maximum and absolute minimum. So let us begin with the definition of absolute maximum. So we are provided with a function f of x, which is a real function, and this function is defined on the interval I. So let's try to sketch this particular graph, and a function which is defined on a particular interval. So let's say this is the point x equals to x1, and this is the point x equals to x2. Our function f of x, which is a real function, and this is defined on this interval, that means all of our values lying between x1 and x2. Then this function is said to have the maximum value in I if there exists a point a in this interval such that f of x is less than or equals to f of a. That means we are saying that there is a particular value within this interval x equals to a such that the corresponding value of this curve on the y-axis will be f of a, and this value f of a is going to be greater than all the values of the function within the interval. So that means if we are to consider any other point on the curve, let's say this is our f of b, and this is, let's say, the point x equals to c, so this will be f of c. So our f of a is going to be always greater than any other value of the function lying in the curve. So that means this particular point, this point is going to be the point of absolute maximum. This is the point where the function attains the maximum value. So this will call it absolute maximum of the function f. So let's try to understand this idea with the help of an example. So let's suppose we have a function f of x which is given by negative x minus 1 squared plus 10. Now clearly x minus 1 squared is always going to be a positive number regardless of the value of x. Even if we choose x to be a negative number, by squaring it is always going to give us a positive number which will be greater than 0. Now if we multiply with a negative number or negative 1, then the sign will flip. Now we're going to add 10 to both sides. So we have negative x minus 1 whole squared plus 10 is less than 10. This is our function f of x, which is less than 10. And what is 10? If we substitute the value of x with 1, then we obtain the value 10, because 1 minus 1 will be 0. So this value is f of 10. So here we are saying that x equals to 1. This is the point of absolute maximum, and the function attains a maximum value of 10, because at this particular point all the other values of fx is going to be less than for that particular value of f of 10. This is f of 1, not f of 10. At f of x equals to 1, we obtain 10. Now similarly we can define the absolute minimum. So we have the function f of x, which is a real function and is defined on the interval I, and the function fx is said to be a minimum value in that interval I if there exists a point a on that interval I such that f of x is always greater than f of a. So let's try to understand with the help of a graph. So let's say we have 2 points on the x-axis, which is x1 and x2. So we consider the graph within this interval. So this is our function f of x. Now we will consider a point x equals to a within the interval, that means lying between the point x1 and x2, such that the value of the function, so this will be the corresponding value of the function f of a. So this value f of a is always going to be less than any point we consider on the curve. So we consider, let's say, this particular point which is b, then f of b is always going to be greater than f of a. Even if we choose a point, another point to the left of x equals to a, let's say at c, then f of c is also going to be greater than f of a. So that means this particular point is the absolute minimum point of the function f. So this is where the function is attaining a minimum value. Let's understand this with the help of an example. Let's say we have a function f of x which is given by x plus 5 squared plus 1. So we know that x plus 5 squared, this is always going to be a positive number. So if we add 1 to both sides, so we have x plus 5 whole squared plus 1, which is exactly the function f of x. So we're saying f of x is greater than 1. And we know that at x equals to negative 5, so negative 5 plus 5 squared, so this will become 0 and we're left with 1. So this is f of negative 5. So here we are saying that x equals to negative 5. This is the point of absolute minimum, and at this point, this will be the lowest value attained by the function, which will be 1, and it is always going to be less than f of x. So this is how we can define the absolute minimum. So let's try out. So before that, we also need to talk about one more thing. So generally these point of absolute minimum and the point of absolute maximum are also known as extremas or extrema points. So that can be obtained. We need to introduce one concept called critical points. So let's talk about critical points. So generally at critical points, the function attains either a minimum value, we get a minimum value of f, or we can get a maximum value of f, or f can be undefined. So these are the three scenarios when we obtain critical points. So that means it could be either minimum value of f or maximum, or f can be undefined as well. So that means there is some discontinuity at that particular point. So that is also be considered as a critical point. So generally what happens in critical points, we take the function f of x and we find its derivative with respect to x and then equate it to 0. So when we solve that particular equation, then we'll get certain values of x, and these values of x is going to give us the critical points. In other way, what we are saying is, whenever we have a function, let's say this is our function f of x, which is lying within the interval x1 and x2. Here we can consider 2 points, x equals to a and x equals to b. So we can say that at x equals to a, where we have a minimum value, and at x equals to b, we have a maximum value. Here we have 2 critical points, and when we draw the tangent to the curve at these 2 points, we see that the tangent line will be parallel to the x-axis, meaning it is going to have a 0 slope. So in other way, what we're trying to do, we are trying to find the derivative. So derivative of the curve will give us the slope of the tangent line, and when we equate it to 0, we can find a particular point a or b, which will tell us that it can be either a minimum point or it could be a maximum point. So let's try to understand this particular idea with the help of few numericals. Example number 1. Let's say we have a polynomial function which is given by x cubed minus 3x squared minus 24x plus 2. So there we have a function f of x, and we want to find out the absolute maxima and minimum value of this particular function on the interval -3 and 5. Let's do that. So what we will do, first we will consider the function f of x and then find out its derivative with respect to x. So we'll find out f prime of x. So derivative of x cubed will give us 3x squared minus derivative of 3x squared will be 6x minus derivative of 24x will be 24, and derivative of 2, since it's a constant, it will be simply 0. Then we equate this to 0, and this is going to help us find a critical point. So that means we have 3x squared minus 6x minus 24, that's equals to 0. We can factor out 3. So we have x squared minus 2x minus 3 times 8, it's 24. Fine. So this gives us x plus 2, 3 times x plus 2 times x minus 4. This will be equals to 0. And when we solve this equation, so this will be -2 and 4. So these are the 2 critical points. So here the function could be either minimum or maximum, we do not know for sure. So what we'll do now, we will find out the value of fx at these two critical points and as well as at the end points. So let's say we consider the first endpoint, which is -3. So that means we need to substitute our function f of x with -3. So this gives us -3 cubed minus 3 times -x3 squared minus 24 times -3 plus 2. So this will be equals to 20. Then we calculate the value of the function at x equals to -2. So we will obtain the value 30. At x equals to 4, the value of the function will be -78. And finally, at the other endpoint, at x equals to 5, the value of a function is -68. So here, -78, this is the smallest value possible for the function. So we will calculate this. This is our absolute minimum. And out of the remaining 3, we'll see that plus 30, this is the maximum value. So this will be our absolute maximum. So that means at the point x equals to -2, the function obtains the maximum value, and at x equals to 4, the function obtains the minimum value. Let's consider another problem. Let's say we have another polynomial function g of x, which is given by 3 times x raised to the power of 4 minus 16x cubed minus 42x squared plus 120x plus 55. And we need to find the absolute maximum and absolute minimum of this particular function on the interval -3 to 10. So this is an interval. So let's figure it out. So we'll begin by first finding out the derivative of this particular function. So derivative of 3x raised to the power of 4. So this will be 12x cubed minus derivative of 16x cubed will be 48x squared minus derivative of 42x squared. So that will be 84x plus derivative of 120x will be 120. So this is plus 55, which is a constant. So its derivative will be 0. Then this can be also represented as 12 multiplied to x cubed minus 4x squared minus 12 times 7x plus 10. We have a cubic function, and if we factorize it, this should give us x minus 1 times x plus 2 times x minus 5. So this is our derivative of the function g of x. In order to find out the critical point, what we will do, we will equate this value to 0. So that means we have 12 times x minus 1 times x plus 2 times x minus 5. This is equated to 0. So this gives us 3 values. So x1 will be 1, x2 will be -2, and x3 will be positive 5. And all the 3 values lie within the interval -3 and 10. So let's find out the value of the function at each critical point as well as the endpoint. So we'll begin with the endpoint g of -3, and we'll substitute the value into our original function g of x. So we should get, so this will be -8. For x equals to 1, the value will be equals to 120. For x equals to -2, the value will be -177. For x equals to 5, the value will be -520. And for x equals to 10, the value will be 11,055. So from here, we can see that the lowest value possible is -520, and the highest value will be 11,055. So here we will say this is our absolute minimum, and at x equals to 10, we obtain the absolute maximum. Let us move on to the next problem. So we have, let's consider the function given by x plus 1 over x, and we have to consider the interval 0 to 4. So we need to find out the absolute maximum and the absolute minimum. So we'll begin by first taking the derivative of a function h of x. So that will be derivative of x will be 1 and derivative of 1 over x will be negative 1 over x squared. So here what we'll do, we'll equate this to 0. That means we'll find out the critical point. To do that, we take the derivative of h of x and equate it to 0. We have 1 minus 1 over x squared equals to 0. 1 over x squared equals to 1. X squared equals to 1, or x equals to plus or minus 1. Here minus 1 does not belong to the interval. It's not equals to minus 1 since it does not belong to our interval 0 to 4. So we'll only consider x equals to 1. However, there's not only one critical point. There is actually one more critical point, and that is our value at x equals to 0. H prime of 0. So this is 1 minus 1 over 0 squared, and this is undefined. So that means we also have a critical point at x equals to 0. So let's calculate the value of this function at the critical points and including the endpoint. So x equals to 0. So this is the critical point including one of the endpoints. So this will be undefined because we have 1 over x. Then at x equals to 1, so this will be 1 plus 1 over 1, which is equals to 2. And at x equals to 4, we have 4 plus 1 over 4, and this is 4.25. So undefined in the sense, here we'll have to actually consider the value. If we take the limit, when x approaches the value 0, then x plus 1 over x, this gives us plus infinity. So that means this particular function has got no absolute maximum value. It has got only an absolute minimum value which occurs at x equals to 1. So this is maximum, absolute, there is no absolute maximum, absolute minimum of hx is equals to 2 at x equals to 1. So we only have an absolute minimum value here. This particular function has got no maximum value. Let's move on to the next problem. So we have the function x times e raised to the power of negative x. So let's try to find out its absolute maximum and minimum value on this interval 0 to 10. So we have to take the derivative of a given function. So here we'll apply the product rule. So we have x multiplied to derivative of e raised to the power of negative x plus e raised to the power of negative x times derivative with respect to x of x. So this will be x times e raised to the power of negative x times negative 1. Here negative 1 is obtained by using the chain rule where we have taken the derivative of negative x plus e raised to the power of negative x times 1. So this gives us e raised to the power of negative x times negative x plus 1. So this is our derivative of our original function. Now what we'll do to find out the critical point, we will equate this to 0. So we have e raised to the power of negative x times x plus 1 equals to 0. So here this value can never go to 0, the exponential function. This is always going to be positive, or it's as a non-zero entity. So that means we'll have only one critical point at x equals to 1. So let us now calculate the value of the function at each critical point. So we have f of 0. So this will be 0 times e raised to the power of 0, which is 0. At x equals to 1, we have 1 times e raised to the power of negative 1, which is 1 over e. And this value is approximately equals to 0.368. At the other end point, x equals to 10, we have 10 times e raised to the power of negative 10, which is equals to 10 divided by e raised to the power of 10. And this is going to give us a value 0.0005. So here we have the absolute minimum which occurs at x equals to 0 and our absolute maximum value which occurs at x equals to 1. So these are the two, absolute minimum and maximum value. Let's move on to the final problem. So we have a function given by e raised to the power of negative x squared. So this is the bell curve because it has the form of a bell with a value of 1 at the origin. So this is our function g of x. What we need to do is find the minimum and absolute maximum and minimum value within the interval -3 and 3. So let's find it out. So first we'll begin by taking the derivative of this particular function. So we have to take the derivative of the exponential function. So here, let's first write it down, e raised to the power of -x squared. So here, if we assume that -x squared is equivalent to x, then derivative of the exponential function gives us the exponential function. Now this will be multiplied to derivative of -x squared. So what we have done is we have used the chain rule here. Now taking the derivative of -x squared, so this is -2x times e raised to the power of x squared. So this is our derivative of our original function. Now we equate g prime of x to 0. So that means we have -2x times e raised to the power of -x squared is equals to 0. So e raised to the exponential function can never be 0. So the only possibility will be x equals to 0. So this is a critical point. Now what we'll do, we'll calculate the value of our function at the endpoints, including the critical point x equals to 0. So let's begin at x equals to -3. So this will be e raised to the power of -3 squared. So that means e raised to the power of -9. So e raised to the power of -9. So this gives us the value 0.000123. Then similarly at x equals to 3, this will be also e raised to the power of -9, which will be 0.000123. And at x equals to 0, then we have e raised to the power of 0, which is going to be 1. So this is going to be our absolute maximum. So this is the point x equals to 0, where we obtain the maximum value of the function with value of 1. And there will be two minimum absolute value points, absolute minimum value points, so both occurring at x equals to -3 and +3. So these will be absolute minimum. So this is how we can obtain the absolute maximum and absolute minimum of a function. So see you in the next lecture. Thank you.